Hello, welcome back to BlenderSushi Live Noding. In this video, I'm going to explore one of SquareChalk nodes. It's just the circle nodes, but I'm gonna explore it in a way that so that we can create something that looks like this spiral staircase. And as you can see, this is like a quite a funky looking spiral staircase because each one of the step has a different have different angle. Um, let's see how we can achieve something like this and start from scratch. So let's switch to compositing and let's create a new node 3 for SquareChalk. Let's delete the default cube and the lamp and the camera. Let's save this real quick. This is gonna be SquareChalk circle pi 001. Okay, let's create a new node 3 and let's generate a circle. Okay, let's start with a circle and let's observe this circle node a little bit. Let's create a viewer draw and plug that in. Plug the polygon in. Okay, we have this circle and lots of usage of circle. You can have like circle that's with a face like this, or you can also use the one with edge, and perhaps use something like extrude edges to do the extrusion. This way you can create some kind of ring, for example. I'm gonna show you real quick. But this guy right here is quite interesting. It's probably not the most obvious. It's not the easiest to understand once if you look at it, and then you might think, okay, that's a circle, and that's supposed to create edges. But you will see that's not really that simple because we need to provide these matrices. Let's do that real quick. Matrix in, and here let's if I provide like random vector, see you see how each vector actually has kind of like directions where it thinks it should go. That's if you're using random. But you can also use vector scale. So vector in, plug into the scale, and now we kind of scaling the vector all in the going outward like that. So this can be really powerful, even though it's not. It's a little bit. This extrude edges is quite complex. There's something that I would like to revisit at some point. For now, we're just gonna perhaps deal with a circle. So let's delete this. Go back to our circle. This is not the circle that we're gonna use. I'm just gonna show it to you. The radius give you control of the radius. Of course, you can have like a multiple input coming into the radius. You can control the vertices and also the degree. The degree for circle, actually, if you're using it like this, maybe not so useful unless you wanna have like half of circle, or yeah, that's not so useful unless you turn on the modes. And now you have something that looks like a pie. So if you have like a 360, so it's covering the pie. If you open it a little bit, so it's something that looks like a Pac-Man. See, there's a Pac-Man. But the one I'm interested in today is how we can kind of control the degrees and generate something that looks like a spiral staircase. Okay, so and I want to kind of play around with this. In fact, this circle node is quite powerful in itself because it's doing like this factorizing. If we provide like a different radius, like a bunch of radius, it's gonna generate circle of that amount, and giving random vertices also give you different number of vertices for each generation. To be really clear, I will use a matrix in. I'm gonna give it a bunch of transform. Give it a line, and this line, if you I tend to use line, although probably for clarity I shouldn't, but basically I use line often because with the vertices I can use it as the transform. If I show this to you, if I generate some lines, you see that's the default line. It's going in the x-axis, and oftentimes I just want to have the vertices, the vector for the matrix in, because it's kind of giving me the quick access to like an array of points going in one direction. So, and oftentimes I'm doing this as well, vector out and vector in, and the default is going in x. We want it to go up, for example. So this vector is the one I like to use. Of course, instead of using line, we can also use a vector in, like this, vector in, and then number range integer or range float, and with step. Maybe actually I think this is a better way to do it. So yeah, either use line or this. With line, it seems to be simple sometimes. Okay, so I'm just gonna use this range float, and it's going in a 1 unit per step, and I have count 8 for 8 number of steps. Let's create an integer. This is gonna be our count. Let's say we have 5, and let me delete the grease pencil, and here as well I'll delete the grease pencil. Alright, so we provide this 5 transform coming in for our pi. So now we have 5 pi, but they're all the same. We're soon gonna change this. Depending on the degrees, we can make a lot of changes depending on what input you give in here. For example, with the radius, if we give in like a bunch of different radius, for example, let's try random radius for starter. Random. For the count, we're gonna use the same count as the transform we give it. Random plug into the radius. Now we have random value for our pi. We can actually use this circle pi to generate like maybe like a van, like a kind of Oriental or Japanese fan or Chinese fan. But anyway, this we can have multiple pi, but all with different size like this. It can be like for flower petal as well. So a lot of usage for even for this circle pi. And with this random, we can really also map range and give it a value that's so more control really. And if you really want, we can also rotate this guy, whether it's a random rotation or rotation that grows. It's totally up to you. Let's give it an axis. I'm gonna give it a rotation axis in the Z. Plug in there. Now with the angle can be, let's say random number. Let's see. if a random number, this is gonna be a small value, so we need another remap node and give a value between minus 30, 360 and 360. So let's see what we got. Yeah, that's pretty cool. Maybe reduce the step and also remove the points, just hide the points. Maybe turn on the shading. We can actually turn on the ambient occlusion as well. Give it a different color. Yeah, that's quite interesting looking. It's quite unusual design that you can create really quickly just by using the circle node. The radius we can expand it. So this is not yet like a spiral staircase, but this is quite interesting looking. You can keep growing it randomly, so it might be like a kind of like alien looking building maybe. With the radius we can make it so instead of random we can use float range float, and perhaps start and stop with count and use it like this. Okay, maybe start 10 and then stop at around 2, so it's kind of it's kind of like a pyramid. I don't know, like a spaceship. I think that's quite interesting looking. It's quite beautiful. Yeah, lots of possibilities with a circle. Basically, the vertices we can increase or decrease. The degree, of course, is the pi. So it's actually with the degrees, it's kind of a clamp at 360 and between 360 and 0. So that's something we need to kind of remember. So yeah, that's interesting, and that's pretty random. I'm gonna save this. Save to new blend. Now I want to make something that's a little bit maybe a little bit more useful. Kind of like a pie chart, but it's for our staircase design. So if I try to draw it, switch the tool, paint stroke, paint curve, change this real quick. Alright, okay, so it's white, but it's okay. Pie chart is basically like this, and oops, stroke using grease pencil, turn that off. Okay, that's a full circle, full pie. Normally, if you want to do a pie chart, you want to know like the percentage of each pie, but the total should be like a 360 degree. For what we are doing, I think I'm gonna use I don't want to calculate the 360 rotation, and what I mean is I want to create a setup where I can give like a maybe start with 30 degree pie, and the next pie should be rotated 30 degree, and maybe this one is like 60 degree, and the next one should be rotated 90 degree, and then this one maybe 15 degree, you know, like continuously rotating like that. Yeah, so how are we going to do that? Let's have a think. So there's a math, there's a little bit of math here. Let's make the radius the same for now. We can keep the rotation in the Z, and this gonna change real quick. The position, yeah, we can keep it. We can keep this guy. So supposedly, let's say we have like 3, and currently they are all the same pi. Okay, it's the same 30 degree, except that they're being rotated. Now let's suppose we want to specify the degree. We can use like a formula. This is one interesting thing about SphereChalk. You can actually give it a list. Let's say first one is 60 degree, second one 30 degree, and the last one is maybe 45 degree. So this is a list of angle that I put it. So SphereChalk's kind of creating the pi in that value, in that order. Okay, to make it even simpler, I'm gonna make like 60, 60, 60, and 180. So I will have like 4. So you can see it's a 60 degree, 60 degree, 60 degree, and 180. But they are, although they make like a full 360, we need a way to kind of automatically rotate them accordingly. And we learned this before with a stacking example. So we can do the same thing with the rotations. There is the list modifier here, that if we use the accumulative sum, we're gonna get what we want. I'm gonna show it to you, the result. So this is exactly what I was talking about. If the first pi is 60 degree, the second pi should be rotated in like 60 degree, and then the next one should be rotated 120 degree and 180 degree, and to make 360 degree basically. So unless I am wrong and I need to add something more, so the first one should be 0 degree, so it's not completely correct at the moment, but we have the accumulative effect anyway, so we can probably just easily add 0 at first. So this is a float, output as list. Let me cut that. Maybe I need to join it first. List join. Okay, list join. So this should be plugged in there. That's 0. This should be 0. This should plug this in there. So okay, that's probably better. Mix and wrap. No, I think that's alright. 0, 60, 120. Yeah, I think that's correct. We can use this value, plug into the rotations, and hopefully we get what we want. It seems to be correct, except that it's the last one is like a 360 or something. 1, 2, 3, 4. So 0, 60, 120. Let me check here. Let's try 30, 60, 90. That's like 210, 150 here. So 30, 30, 60, 90 degree, 150, and one more. Yeah, it's okay, we can have like excess. But anyway, I think we have our accumulative, we have our pie, kind of like a pie chart that's keep accumulating. So let's say instead of providing the value like this, we want to have a value that's kind of repeating, maybe 60 degree every 60 degree. So we can do that easily. Create a list repeat, plug the data there. Let's check the value at the moment. Let's say we want to have 5. So the list looks like this. Compared to our formula, we probably need to change this a little bit. Not unwrap, perhaps level 2 and unwrap. Now it's matching our formula, so we can use this now. Plug this into that guy and this into that guy. So now we have a pie that's 60 degree and keep growing. If I make changes, it's gonna update it. It's kind of like having like a cumulative kind of effect, so that's exactly what we want. Oh, cool. All right. Here with the number thingy, we can now have something that looks like a stair almost, except that it's growing down. You can make it growing up. So this is more like a pie chart, but it's a yep, that's all right. I think this it looks correct. Let's check it from the top. View orthographic. I have a feeling that it's slightly off, but still kind of alright. Maybe I made a mistake with the here another step. Maybe it's step 0. It's something to do with the angle, maybe with the accumulative. Okay, the starting point is not 0. Nope. No, there's a list repeater. So that's the starting point. I guess that doesn't matter so much. That it's a slightly off by a few degrees. By 30 degrees actually. Okay, that's looking all right. Now that we have this set up, I'm gonna save it. Save as. I'll probably gonna share this setup at the gist at the GitHub. It's gonna be in the description of this video, so you can always reload this setup for you to use. So here the radius. Yeah, we can randomize the radius, so that's no problem. The vertices, we can change it. Doesn't matter too much. So that's the angle. This is the circle. So we accumulate the angle based on this value we are providing. This is actually the 60. It can be any value. You can see it's kind of nice to have this. You can give it like 15, and yep, there you go. That's a spiral staircase. And if you really want, we can probably animate it using animation nodes if you really want to, or even using sphere chalk itself. The way to do it is just to maybe use like the angle math here, give it an offset. Oh, actually this one doesn't like, because it's like a list and it doesn't take it. Maybe we can use MK2 image output. Okay, MK2, and then plug this to there and this to that guy. Hide the viewer. Oh, the matrix. Okay, we need the matrix. There we go. That's our stair. Yeah, if you really want, maybe I'll turn on animation nodes real quick. And switch. And maybe in SphereChalk I will group the output, group it, and then update. Now they are grouped. In animation nodes, we can get objects from group and simply animate them. Object transform, output, objects rotate. They are back to 0, 0, 0. Oh well, but the thing is about with animation nodes is we can use this index and iterations. That's a kind of things that I found super useful. Multiply, add, divide. So divide the index by iterations, and we should have I probably need to multiply it. Okay, Euler, combine Euler, use degree, yes, rotate it in the Z. Use degree, no. Maybe use multiply. Yeah, that's kind of what I was thinking. No, although I probably need to do like a little bit of research on the math here. Use degree, okay, use degree and rotate it. Wonder why the bottom, maybe the sorting is not correct with this grouping. Let's sort, group sort using directional. Okay, that's better. Give it a 360. There you go, that's a 1 spiral. 720 give us twice. 3 times 360 give us 1080. So it's 3 times spiraling. You can rotate this, of course. Maybe on top of this we want to also Euler math. And plug in the frame. Do that. So now playback. So it's rotating spiraling stair math. There you go. I think that's quite a nice effect. So there you go. Something that looks like a spiral staircase. Yeah. So, and we are just using node like this. That's the final objects, but this is the one we have as a preview. And so there you go. Of course, for a real staircase, you need to have the rail and the center point, and maybe have control over this point. Maybe you wanna cut it. I don't know if StraihtChalk have a stair creator. Maybe one of the nodes. But anyway, this is one way we can approach this spiral staircase problem. But of course, you can see that the circle is really highly useful, and I'm gonna share this in the gist. Gonna export this, export, import, export, and pi. Just call it maybe sv spiral pi. Save. So that's the JSON. I'll share it in the link down below in the video caption. Anyway, thanks again for tuning into this video. If you want to have question, just leave it in the comments down below, and I'll see you in the next video. Thanks again.